Hello, my name is Peter Kasianchuk, and I'm an instructor with the Educational Services Department with ESRI in Redlands. Joining me today is Paul Hardy, who is the Cartographic Product Manager, also located with ESRI here in Redlands. And we want to welcome you all to today's live training seminar, Introduction to Cartographic Representations in ArcGIS 9.2. Here's what we'll be covering today. We've got a lot of material to go through, and I'm sure you have a lot of questions. The first topic area will be an introduction and definition of what cartographic representations are and why you might want to use them. The second topic area will discuss working with representations in ArcMap and ArcCatalog. And the third topic section will review the new geoprocessing tools that work with cartographic representations. Each of these topic sections will include a software demonstration, a brief review of what we just covered, and most importantly, a question and answer session. I know that this is a new topic of interest to most of you, and I'm sure you have a lot of questions. For those of you who are new to the live training seminar experience, I encourage you to type in your questions now so that they get into our question queue in time to have as many answered as we have time for. So let's move into the topic information. The first one is defining cartographic representations. The release of ArcGIS 9.2 contains powerful new functionality for managing feature symbology within the geodatabase. By an intelligent way to symbolize features, we mean that you can define feature symbols to automatically draw the same way every time they're added to a map based on a set of user-defined rules. The purpose behind the development of these tools is to make it easier for you to perform cartographic tasks that may currently require time-consuming manual data editing or other techniques that were simply not possible with previous versions of ArcGIS. Because representation feature symbols are stored within the geodatabase, you can take advantage of a single data source for both feature geometry and symbology, and easily reuse or share this information across your organizations, and your maps will look consistent. Cartographic representations are stored as a property of a feature class. Feature symbol definitions are stored within the geodatabase rather than in a layer file, map document, or style file. And you can manage them through as a layer property in ArcMap or as a feature class property in ArcCatalog. And I'll demonstrate this shortly. I should emphasize now that representations do not replace existing file-based storage symbols. In fact, they work seamlessly with the file-based methods you're used to. So layer files, map documents, and custom styles are still important and necessary. So to re-emphasize that, cartographic representations are not a new data type or a new layer type. They are simply a new way, an augmentation to store symbology. So why would you want to use them? Well, in the first place, they are a better, more efficient way to create and manage complex symbology, allowing you to create better-looking maps. Representations give you the ability to store multiple sets of symbols for different types of maps. For example, you may have a feature class which contains line geometries for bicycle trails. You might want to have one set of trail symbols for a tourist map, but a completely different set of symbols for city planning or emergency services maps. And as shown here on the screenshot, you have the identical data being shown with two different sets of representations. In addition, some cartographic tasks that were possible in previous versions of ArcGIS but time-consuming may now be automated through the geoprocessing framework. And we'll discuss some of those new tools in the third topic section. With previous versions of ArcGIS, editing feature symbols for clearer maps required that you would also have to edit the underlying feature geometry. Cartographic representations allow you to disconnect that relationship so that if your data belongs to a geometric network or a topology, you don't have to create new data to manipulate the symbology. So this brings us to our first software demonstration. In addition to storing the symbols in the geodatabase, you now have the opportunity to edit features independently. Let's take a look at how this works and how easily you can convert your existing symbology into representations. Here we are in ArcMap, and we have a rich set of symbols already defined within a map document as stored and defined with a typical layer file. So this is behavior that you're already used to. The data that we're looking at here is from Austin, Texas, and this is the data that will be available with the representations tutorial that will ship with ArcGIS 9.2. Let's zoom in to a little bit more detail to take a look at a specific set of symbols that we want to convert to representations, specifically this roads layer. You'll notice that we have a number of different road classes with some potentially fairly complex symbology, and review how this is currently stored. So we'll look at the layer properties, and you'll see here that we have 3 different road classes. By double-clicking on this particular symbol for the road class 2 and looking at its properties, you can see that we have a number of different layers that comprise this individual symbol, each of which have their own properties. So this should be familiar to all of you, but what you'll also recall is that I've already drilled down about 3 panels deep, and for some of your other complex symbology, you may have to drill down even further. So one of the major differences that you'll see when you convert the symbology to representations is that we give you a single interface to manage all these different properties. So what I want to do is convert my existing symbology into a representation. And in ArcMap, where you already have this stored and defined in a layer file or a map document, this is a very easy process, essentially 2 mouse clicks. I'm going to right-click on this Road L layer, and you'll note that in the context menu, we have the choice to convert symbology to representation. So we'll take a look at these default settings. First of all, we apply a name to this representation. There will be 2 new fields appended to the feature class attribute table with some default names, rule ID, and override, and we'll keep those. You'll also notice that there is this default behavior. If you need to edit any of your feature representations, you can choose to store that change as a representation override in this override field. You also have the option, should you choose to change the geometry of the underlying feature. That is to say, change the geometry stored in the shape field as well. You might not want to do this, but you can if you want to. We're going to convert all the features and simply use the same layer file that currently exists in the ArcMap table of contents. So I'll click Convert, and you'll see that the symbology has remained essentially the same. However, there are 2 substantial differences that I want to point out. I'm going to go back to the layer properties of this road layer, and you'll see that what has happened is that I'm still on the Symbology tab, but automatically a new representations renderer has been added to this list of show and automatically applied. And we'll take another look at this class 2 road that we looked at previously in the layer file, and you'll note that all of the individual layers, symbol layers, have been converted to representation symbol layers. So you can see that the 3 different symbol layers that comprise that class 2 road are now converted. You can also easily change the properties of these. What I want to do is make this line, just the black line underneath here, a little bit thicker so that it's more easily visible. So I can simply change the width of that underlying black line dynamically, and as you can see, it automatically updates the symbology associated with this particular class 3 representation rule. So that's the first significant change that you'll see in the ArcMap interface when you convert symbols to representations, is this new representation renderer. We'll discuss this in a little bit more detail shortly. The other change that you'll notice is in the feature class attribute table. Let's open that. And you'll notice that when I converted those symbols to a representation, the rule ID and override fields were automatically appended. The rule ID field stores a series of integer values which correspond to those representation rules that I just showed you. So integer number 2 is a class 2 road, and if I chose to scroll down, you'd see other values that apply to those individual features. There are additional system tables that are not exposed that actually store the symbology associated with these integers. The override field currently stores no information. We haven't made any edits. But if we were to make edits to individual feature representations, those changes by default would be stored as a binary large object in the override column. So that's a brief demo of how easy it is to convert your existing symbology to representations using ArcMap. I'll briefly show you how this also is exposed in ArcCatalog. So in this case, just to confirm that we are in fact dealing with geodatabase storage, by moving to ArcCatalog and selecting on the road layer, I'm going to right-click and look at the feature class properties, and you can see that there is at ArcGIS 9.2 a number of new tabs about one specific to representations, and this road L rep has been added, and we can examine the properties of that feature class representation and the individual representation rules contained within it. You'll notice that this is currently grayed out, and I can't make any edits to this because there is a schema lock. I already have this data open in ArcMap, so I can't do an edit right now from ArcCatalog. So that's the first simple software demo. What we've just done is introduced cartographic representations as a new way to symbolize data and store that symbology in the geodatabase. The purpose is to enhance your map visualization and potentially automate some of your cartographic data management tasks and improve the efficiency of your map production workflows. So hopefully this has generated some questions. I'll turn it over to Paul to spend a few minutes answering some of your questions. Paul?
Hi, I'm Paul Hardy, Product Manager for Cartography. I was also the Program Manager on the software engineering to get this new representation functionality into the 9.2 release. So we've got quite a few questions coming in. I'll group a few of them together. There are a set of questions associated with licensing. Basically, are all the tools available in all licenses of ArcGIS? So let's break that into parts. Firstly, on visualizing representations. If you've got cartographic representations set up, then you can see them, display them, plot them in all license levels of ArcGIS, including ArcReader, so ArcPublisher knows about it. You can produce maps with them with ArcGIS Server, and in the ArcIMS suite, you can see them using the ArcMap server for ArcIMS. So the only parts of the ArcGIS family that don't know about representations are ArcPad and ArcIMS High Performance Server. So you can, the extensions also know about them, so the 3D, ArcGlobe, ArcScene can also display representations. So then the next question on licensing is, what licenses do I need to create representations and to manipulate them? And there the answer is you need ArcGIS Desktop with something more than ArcView. So you need ArcEditor as the base license or ArcInfo. ArcView, you can see them, but you can't create them. There are then two questions. Peter in Phoenix asking, how does representation affect performance? And another person asking, will the representation work with file-based geodatabase? So taking performance first, the drawing performance is at least as good for most representations as it is for the existing symbology. We did a lot of optimization on there. Clearly, using the representation rules, as you'll see later on, you can set up more complex symbolizations than you could with ArcGIS 9.1. The more complex the representation, the slower the drawing. But like for like, it's actually usually faster. The question on, does it work with file-based geodatabase? Yes, you need a geodatabase is the first thing. You can't do representations directly from shapefiles. You'd have to load your shapefile into a geodatabase. But it then works with any of the types of geodatabase. So the traditional personal geodatabase, the MDB file that was supported in 9.1, but all the new kinds of geodatabase also that are supported in 9.2. So the file geodatabase, the personal SDE, the workgroup SDE, and of course the enterprise SDE. So you can use any of those geodatabase types. So at that point, I'll hand back to Peter and we'll take some more questions later on.
Thank you very much, Paul, and thanks for your questions. Please keep them coming in. Let's move on to our second topic area, which will be a little bit lengthy and has 2 software demonstrations associated with it and a question and answer session at the end of the second demo, where we're working with representations in ArcMap and ArcCatalog. Once you have defined or created a feature class representation, you then define a set of symbols called representation rules. Now, these are similar to symbol categories you have already created and stored within a layer file, as I just showed you with that roads layer, but now they are defined and stored in the feature attribute table. So as you see, it's very easy to convert them from existing feature layers. Again, you symbolize features independently of the spatial geometry, and you can manipulate that independently as well. As I've just shown you, there are interfaces and tools to manage these representation rules in both ArcCatalog and ArcMap. So let's look at these in a little bit more detail. You will probably work primarily in ArcCatalog to create and visualize representation rules, as it is the more graphical environment. And as you've just seen, you assign and manage these representation rules through layer properties on the Symbology tab in ArcMap. A brief review of the interface that you just saw in the software demonstration, we now have this new representations renderer. And the example that we're showing you here with this roads layer is that you can see that there are 2 feature class representations present with this particular feature class. We have road LREP and then another representation underscore 50K. So this gives you an idea that you can store more than 1 feature class representation. You need to define which one you're going to use. In addition, when you first load a new feature class into a new ArcMap document, the default renderer, that is to say the single symbol per feature, will be applied. You then need to go into the layer properties and apply the representations renderer to take advantage of that symbology. In the center section here, you have control over creating and managing your representation rules. So as you can see here, we started with this default that we imported from the existing symbology, but we added a new representation rule called tunnel in this particular case. You can add, load, or save these with the pull-down menu here, which is rule properties. On the right-hand side, you have the ability to define properties for individual representation rule symbol layers. And that's what you saw in the first software demonstration. Each one of these independent symbol layers has properties that you can explicitly define by simply typing in different values. And you saw that I already did that with that class 3 road by widening the black symbol layer. There is also another mode called the field overrides mode, where by clicking on this button at the bottom right, you can, instead of explicitly defining values, you can associate a layer property with a feature attribute which may already exist in your attribute table. So for example, you may have a width field that's already in that feature class attribute, and you can associate that with the symbol layer property. In this case, you will dynamically draw your symbols based on the up-to-date values in the geodatabase every time you load that representation. As you've just seen, ArcCatalog also gives you representation management tools. This would be where you drop feature class representations. You can add them new. And the primary intent of the management tools in ArcCatalog is to create representations or assign representation rules to new data that does not already have symbology defined. I should also reinforce what Paul has mentioned, that the representation renderer is available with ArcReader, ArcGlobe, and ArcGIS Server, so that you create and manage cartographic representations in ArcGIS Desktop and deploy them across many other ESRI applications. Once you have defined a library of representation rules using basic geometries of marker, stroke, or fill geometries, you then have tools to further enhance that symbology. Geometric effects are applied to the representation symbols as they are drawn, and they can be applied to all the symbol layers in a representation rule or just a single symbol layer. For example, the class 2 roads that we were showing you had a dash geometric effect applied to only that red layer. So you can see here that from the line input, we would have selected this dash geometric effect. Now, in some cases, you may need to add a new symbol layer to hold the output of one of those geometric effects. For example, you may want to create a buffer polygon around a point input. In this case, you would add a new fill symbol layer and apply the buffer geometric effect. What this means is that you can create new feature symbol geometry from the original input feature geometry. If you have added a marker symbol layer to your representation rule, you can define how those marker symbols are placed in relationship to other symbols in that rule or other symbol layers. You can also mix and match your different symbol layers. You are not limited to having a single symbol geometry based on your input geometry. So you can start to add markers to lines, for example. And we'll show you how this works in the upcoming software demonstration. In addition to geometric effects and marker placements, you also have a marker editor. Representations use their own type of marker symbol. You can import existing symbols from a font, or convert and modify existing markers, or create new ones from scratch in this fully functioning editing environment. You'll note in the top right-hand corner here, there is a rich set of tools which allow you to manipulate any property of that marker symbol. As shown here, we've got individual vertex control. You can control the nature of gradient fills within the marker, within a single interface, and it allows you to create unique symbols for your map or convert symbols which you may already have stored in a custom font. So this brings us to our second software demonstration, where we'll take a look at some of the functionality that I've just described. So in this case, I'm going to zoom to a new use case where I have some polygons that comprise the woody area cover. And in this case, I've already converted these symbols to representations, and I have a particular representation rule that defines orchard, vineyard, grove. And in this case, I'm going to move the interface off just a little bit so that you can see the updates as I make them. And in this case, these two polygons here are orchards. So let's select that representation rule. And you can see that currently this rule is comprised of only a single fill layer with a simple color. So one of the enhancements that I can make is to add a stroke layer because I want to have some kind of outline around this polygon. And you can see that the representation rule symbol is automatically updated. And now I can change some of the properties. So the default line thickness might be a little too wide. And I want to change that to a simple green color and click Apply. And you can see that that renders these new features to which this representation rule has been applied. I also want to add a geometric effect. I want to dash this line. So in this case, I've clicked on that plus sign, and you can see that there are a number of geometric effects available with this polygon input. I'll click on dash, and you can see that there are some default values there, which are automatically shown in this representation rule. I want to change the parameters to these, and you can see now that that updates the symbology for that particular representation rule. I can also add markers. Now in this case, we've got orchard polygons, and what I would like to do is add tree canopies to make this polygon look more orchard-like. So I've added this marker symbol layer, which starts with the default black square and a default polygon center placement. You notice that in the representation rule, you can just see that there is one marker here being shown inside the center of the polygon. Well, I'd like to change all of the properties of this particular marker layer. So I'm going to click on the marker symbol and expose marker selector. This pulls information in from an existing library that's going to ship with ArcGIS 9.2 of representation markers. And there are a number of complex markers in here. but none of them look particularly tree-like. So what I need to do is go out and find some other symbol that I can use for my tree canopies. By clicking on the properties, I now invoke or launch the marker editor. And you can see that the default black marker symbol is what's being shown here. And by clicking on it, you can see that I've actually got an editable environment. So I could actually manipulate this existing one or delete this and start creating from scratch on this empty palette. But in this case, what I want to do is bring in a symbol from an existing font. In this case, I've scrolled to the ESRI US Forestry #2 font, and this will pull in all the information from any of the fonts associated with your operating system, and ArcGIS ships with a number of them that will be installed. And then in looking at this, I know that what I want to add is the Unicode symbol type 100. By clicking OK, this glyph will be pulled in from the font and converted into a new representation marker symbol. I'm not going to do any edits to these individual vertices, but I am going to change the color to a dark green. Click OK. And you can see now that my marker symbol is this tree canopy. Now currently, the placement is still only a single marker within that polygon center. I want to change a few properties to make this look more like an orchard. So first of all, I'm going to change the default marker size. And then I'm going to change the pattern of these markers within that polygon. By clicking on that arrow, I now have the marker placement styles. And I'm going to change from the polygon center to inside polygon. In doing so, you'll notice that the representation rule has automatically been updated, but it's been overprinted with a lot of green. What this means is that the differentiation or the steps between these marker symbols is a little bit too small. I'm going to change it from the default value of 1 to the value of 5 and click Apply. And you can see that I've now got this regular ordered repeating pattern of these tree canopies to make it look a little bit more like an orchard. I'm going to scroll down and show you another property of the marker symbols that you can define. Currently, the default clipping is to clip markers at the boundary of the polygon. What I'd rather have, to make it look a little more natural, is to have the whole markers cross the boundary of that polygon. By clicking Apply, you can see now that whole markers look like whole trees. I'm going to remove this marker symbol layer. Shows you that I've got lots of control over how these complex symbologies look. So a couple of things that I've just shown you: how to add geometric effects, how to use the marker editor, and also the principle that you can add any number of individual layers to arrive at whatever complex symbology you need with a number of different geometries. Hopefully that's generated some additional questions, but let's briefly review what we've just looked at, which is that you've got geometric effects, marker placements, and a marker editor, which will all enhance your representation rules. But let's move on to the next topic section. Currently, everything that I've just been talking about has been dealing with editing functions at the feature class level. So a point of clarification of terms is in order here before we move on. Just as a generic feature class is made up of individual features, so too is a feature class representation made up of individual feature representations. And each of those feature representations has a representation rule assigned to it. So what we're discussing now is the editing of individual feature representations. Now we're expecting that you should not need to perform a lot of edits to individual features. If you find that your map requires a significant amount of editing, you should reevaluate your representation rules and the potential for geometric effects to reduce the number of manual edits you need to make for your map. By default, any feature representation edits that you make will be stored in an override field, or if you have mapped some symbol properties to explicit fields, they will be updated as well. There will be places where you need to edit individual feature representations for improved map clarity. For example, at map sheet edges, where features might need to be moved away from the edge so as not to be cut off. It's a dynamic graphical environment where you apply your cartographic aesthetic sense to define what looks best. As shown here, you may need to move some symbols around. The blue squares show the actual feature geometry for that point geometry, and there are mimetic symbols that have been applied as representation markers for each of those points, which have needed to be moved a little bit for different offsets for improved map clarity. So it's up to you to define how you might want to move symbols based on what looks best on your map. So how do you accomplish this? Well, by using the representation toolbar. This is a new toolbar with ArcGIS 9.2, which works in conjunction with an ArcMap edit session. Now remember that because symbology is stored within the feature class, you're editing the geodatabase, and so the regular editing rules apply. As Paul mentioned earlier, licensing issues, if you can't edit feature representations with an ArcView license, you need at least an ArcEditor license. You'll also need to reevaluate some of your workflow if you are dealing with versions in a multi-user environment. This toolbar contains manual selection and editing tools, and this will be a familiar editing experience for all of you, but recall that you are not editing the underlying geometry. You are using these tools to edit the feature representation symbology. And there are a number of tools, most of which are exposed here in this graphic. Now, rather than go through a long description of each of these tools, I recommend that you consult the ArcGIS 9.2 desktop help for a description of each of these tools and their functions. And you can access this online help right now. Wait till the end of the live training seminar, but go to our support site, and on the left-hand side, you will see a link to the ArcGIS 9.2 desktop help. And I encourage you to go take a look at that. In addition to the manual selection tools shown on the toolbar, you have a representation properties window, which gives you the ability to make specific changes to the individual symbol properties based on the selected feature representation. You'll note that we are looking at essentially the same example as what I was just showing you with that woody area, orchard area. So in this case, we have a single orchard feature representation selected, and we have exposed all the properties that we might want to edit for that specific selected feature. The Drawing tab exposes this functionality. Also in the representation window, there is a Tools tab, which controls the edit properties of the selected tool that you've chosen from the representation toolbar. Warp, rotate, resize, and others will all have slightly different properties that you can control. The example shown here, and the one that you'll also see in the upcoming software demonstration, is the rotate tool. In this particular case, the selected feature has a fill layer and a marker layer. The rotate properties can control both the angle and the grid angle, and by default, both are checked on. You have the control of what you actually want to manipulate or edit with that rotate tool. Where you have made some changes, these will be stored by default as a feature override in that override column. As shown on this graphic, any changes that you make will have an associated icon with this override icon associated with that particular field. So in this case, we've edited both the rotation angle of this marker and the grid angle for this marker set. Now watch the screen animation, don't blink. By clicking on that button, you notice that it disappeared. The rotation angle reverted to the default value associated with that representation rule. The grid angle is still stored as an override. Keep in mind that this behavior works in both directions. If you manually edit your feature attributes, any mapped representation symbol layer properties will automatically and dynamically be updated. So let's take a look at how this works in practice, and then we'll try to get to another series of questions and answers. I'm going to use the same orchard example that we were working with earlier, and just briefly introduce you to some of the properties that you can use to edit this particular feature. Now, the first thing that I want to confirm is that my woody area feature class representation is selectable. When I start my editing session, You'll notice now that the representation toolbar is available. By clicking on the select tool, you'll see now that there are a number of vertices exposed, and this is the selected feature that I want to work with. So the first thing that I want to show you is the representation properties window, just to review how that works. You can see now that I can expose whatever are the properties of that particular selected feature representation. In this case, I might want to make the trees a little bit bigger for only this feature. And you can see this dynamically updates those tree marker symbols. You'll also notice that we now have that override icon that's being associated with this particular property. By hovering over it, you'll see that it turns into a button, and by clicking on that button, I will remove the override and revert to the default value. I could also change the clipping if I wanted to do so. So clip markers at that boundary if I wanted to, or the other property is that no markers touch the boundary. In this case, I'll simply revert to the default value. The other behavior that we've got associated with the representation properties window is the Tools tab. And in this case, I have not yet selected a tool. I'll go to the Rotate tool, and you'll notice that I have two options here. Now, I have a circular marker symbol here, so rotating the angle of that circle won't be particularly visible. So I'm going to check that off. But what I do want to rotate is the grid angle. I can do this manually with the Rotate tool, and you can see that that's the only property being edited right now. And that gives you the opportunity to do manual edits. But I could, in addition, move back to the drawing and actually type in an explicit rotation angle. You see that this dynamically updates. I'm going to close this to zoom in a little bit further and show you that you actually have specific control over individual vertices of your selected feature as well. So this is called the Direct Select tool, and I'm simply going to select those. You notice that the vertex symbology has changed slightly. My selected vertices are filled in, whereas the unselected feature representation vertices are still a hollow box, and I can just pull out these particular features, maybe just this one, and you can see that I've changed the polygon boundary of this particular feature just to confirm that I'm editing only the feature and not the underlying geometry. I have a second layer file that's been added here called the Woody Area No Representation, and this is drawing the underlying geometry without the representations applied. Same feature class, but not using the representation renderer. So this is the information stored in the shape field. This is the representation. So that's all I wanted to show you in this particular demo. Let's get to some more questions, but briefly review all of the information that we've just gone through in this rather lengthy section. We discussed the nature of representation rules, representation management with ArcGIS desktop tools, and how you can enhance those rules with geometric effects and marker placements, and also introduced you in the software demo on how to use the marker editor, and then just recently some explicit edits to specific feature representations by using the representation toolbar. Paul, do we have some more questions?
Yes, we have lots more questions. Firstly, taking a couple about text. Sierra in Bothell says, do cartographic representations work with annotation feature classes? And Jerome and Whitney says, does the Maplex labeling engine work with the feature class or the cartographic representation? So firstly, the cartographic representations don't replace or do away with any of the labeling and annotation system. That's there, it works well for text and labeling, and that's probably what you want to use for most cases. However, the Maplex labeling engine and the standard labeling engine both are aware of representations. So if you have, for instance, a point feature class and you use the representation editing to override the position of one of those points away from its true position to a representation position, then the labeling engine will label with respect to the representation position. So that is an important facility. It does mean that you can displace labels away from the true geographic position without creating an annotation feature class from it. So let's take some other questions. I've lost the one that I was going to answer. Do these cartographic representations honor your display transparency setting in the ArcMap layer properties? That's Ray from Gastonia asking. And the answer is yes. The representation system fits into the existing layers in the table of contents and the layer properties. So for instance, you can set layer transparency there. Another question in my list was can you turn on and off layers according to scale? And that's a related question. There's nothing specific in the representation capabilities for doing that, but there doesn't need to be, because those facilities are there in the layer mechanism. So you can have layers turning themselves on and off as you zoom in and out. And if those layers refer to representations, then the representations will appear and disappear as you move in and out.
I'd like to take one, Paul. Timothy from Cincinnati is asking, can you randomize the tree pattern to make it seem more natural or forest-like? And the answer is yes, and quite easily. I'll stop editing here and dynamically show you how you can do this. So in this particular case, I've got these trees ordered in a grid pattern, but I would simply change the marker placement style here for this to simply put randomly inside the polygon. So click OK, and by clicking Apply, you see that I have it randomly, but those look a little sparse. In this case, I would change the X step and Y step to make it slightly more dense. Click Apply. You could also add a second marker layer and add a different kind of tree symbol, perhaps a coniferous tree crown type to show something like a mixed forest, or some other marker or polygon fill to give you mixed forest with an underlying grassland pattern. So there really is no limit to what you can add into your representation rule to make it look exactly what you want. So hopefully that answers that question. Paul?
Okay. So Belinda in Anchorage asks, can representations be saved out to styles? And the answer is yes. You can save out representation rules to a style. You can save out representation markers to a style. And then you can move that style file from one system to another. And that's the way to get representation rules and representation markers from one database to another. Within the database, when you're creating a representation, you can load representation rules from another feature class, from another representation that's already been set up. So there's a set of tools there for moving these facilities around between systems and between users and between maps. There were a couple of questions about permissions, again, particularly with respect to SDE. I think the useful thing there is to think that creating a representation, adding a representation to a feature class is, from a permissions point of view, is exactly the same as adding a column, an attribute column to an existing feature class. That's what it is. It's adding two new columns, attribute columns that just happen to be interpreted as representations. So you need the same sort of permissions to do that, to create a representation as you would to add a column. When it comes to actually permissions to edit representations, to do overrides, then again, think of that as changing an attribute. It's a representation attribute in this case, but you need the same sort of permission. So you do need write access to the feature class to do an override to a representation in a feature class that's in an SDE geodatabase in that situation. Okay, I'll stop there and hand back to Peter, and then I'll put in a few more questions. We'll have one more of these slots at the end.
Thanks very much, Paul. And again, thank you for your questions. I can see there's lots of interest here. But let's move on to our final topic area, which is geoprocessing with representations. First of all, what tools are there and why would you use them? Just generally speaking, using geoprocessing tools for representations will allow you to take advantage of the general benefits of the geoprocessing framework. For example, you may already have automated routines for data extraction or generalizations, and you can now integrate representation management into these existing tasks. You can automate the creation and management of feature symbology using these tools. In addition, what new functionality at ArcGIS 9.2 is the ability to run batch processes from the tool level. So you no longer need to write a script for that, but you can also take advantage of all the other benefits of the geoprocessing framework using Model Builder, scripts, or access through ArcObjects. What this means is that there might be enhancements or improvements to your current cartographic workflow. You may need to define editing tasks for multiple map editors. You may have some other data import-export automation tools, and some of the new tools available with 9.2 may allow you to improve what you do now. One point to note with some of the tools that we'll be discussing shortly is that typically the representation symbology is processed or evaluated and not always the geometry, but some tools give you the option to modify either. Independently of what you might have set up originally. So something to keep in mind there. All of the new representation geoprocessing tools are located in the Cartography toolbox. This toolbox was originally made available with the release of ArcGIS 9.0, and it still contains the masking tool set, which hasn't changed. So the masking tools still work as they did before and are not specific to representations, but they might work with them. But what we want to discuss is some of the new ones. The graphic quality tool set contains a single tool, which is the Detect Graphic Conflict tool. This tool is intended as a straightforward quality control, which automates what for many of you may be a time-consuming manual map finishing task, where you currently need to print out a check plot and do a manual inspection, possibly with a magnifying glass, of the map to find any areas where your symbols overlap. So this tool automates that process and provides you with a new output polygon feature class where any of your representation symbols overlap. In the example shown here, we have a road, which is a basic line geometry, and a river, which are not coincident. However, once the representation has been applied, these symbols do overlap. So in that particular case, the output of the graphic quality tool is this polygon, which outlines where those symbols overlap. This tool can also evaluate features, representation features, within a single feature class. For example, you might have a buildings layer where you don't want to have any of the buildings drawn within 25 feet of one another. So there might not actually be a direct overlap of the buildings themselves, but you want to find the occasions where they encroach upon one another in less than 25 feet and potentially remove or edit some of those conflicts. Another tool set is the representation management tool set, the name of which is fairly self-explanatory. These tools are intended to automate the management of feature class representations or overrides, and are primarily intended for use with Model Builder and scripts and automating some of the processing. There are also some tools which allow you to manage overrides. So you may not need to necessarily, you may not necessarily be able to see where overrides have been applied. So you now have a geoprocessing tool which allows you to simply pull that information in and give you a selected set. So here are the tools contained within the representation management tool set. Add and drop representations is fairly straightforward. The calculate representation rule will apply a rule to a selected set of features. Select feature by override. Remove or update overrides where they may not have been appropriately applied. And the set layer representation is intended for Model Builder, where you may have more than one feature class representation associated with a single feature class. The third new tool set is the Symbolization Refinement tool set, which is intended to automate what are currently some manual cartographic tasks, for example, some masking. In many cases, they create new cartographic features, or a couple of the tools will simply apply new information to existing feature class representations. And some examples here, the Align Marker to Stroke or Fill tool I will demonstrate shortly. But what we're seeing in this screenshot is the Create Overpass tool. There's also a separate Create Underpass tool. So in this particular case, we have a use case where we want to mask out this river and apply or create a new bridge abutment symbol. So the create overpass tool does all of this in one process, where it creates an output polygon feature class and an output line feature class. You use the polygon feature class to mask that representation and draw this bridge abutment. So what is currently a fairly manual task using the masking tools is automated with this single tool. The calculate polygon main angle tool might have been useful for me with that orchards example. Rather than trying to manually rotate the grid angle for those trees, I could have used this tool to calculate the polygon main angle and oriented the grid angle to that, and automatically rendered the marker pattern based on the main angle of the polygon. Let's take a look at how this works in practice with the align marker to stroke or fill, which automates what might currently be a very manual task for some of you, or simply not possible. So let's turn on these building points. In this particular case, we've got a series of black markers which are oriented in a default north-south direction. Before I do this geoprocessing, I want to show you that I've already set up a property within the representation rule which maps this angle field to an existing attribute. So let's take a look at that field overrides, and you'll see that I have actually mapped this angle property to an existing field in the attribute table of the feature class. Currently, let's take a look at the attribute table. Currently, in looking at the angle field, you'll notice that there are no values associated with that rotation. Now, you could currently go in and start manually trying to figure out what that angle is. But as you'll see when I run the geoprocessing tool, this will be dynamically updated. So in this case, I'm going to bring in building P. I want to orient it to the roads layer. And there's a certain search tolerance that I want to use. I want these to be looking for the nearest road within, let's say, 5 points. These particular features are 2.5 points, so that's like double their size. And you'll click OK. There are about 3,000 features in this feature class, and that took all of 3 seconds to process them. Ooh, now you can see that all of these symbols have been dynamically rotated to the nearest road. You'll notice that there are a couple of symbols that didn't rotate because they were outside of that boundary, or outside of that search tolerance. The other benefit of doing it this way and mapping your properties to fields is that you can see that the attribute table has now been dynamically updated. So all the angle values for all those rotated symbols have been populated by that geoprocessing tool. Of course, this could also work in the reverse. Some of you may already have a rotation angle associated with your current data, and you could simply read in that information based on that property and dynamically render all these points already. But where you don't have that information, you will have a geoprocessing tool with 9.2 that will do that for you. So before we get to the review, which is really more a summary of the entire seminar, I'd like to turn it over to Paul to answer a few more of your questions. Paul?
Okay, thank you. Well, I keep getting questions about privilege and license levels. Sarah in Naperville says, can users have the ability to do representations but not be able to edit the actual geodatabase? And the answer is no, not within that one geodatabase. If you have access to the representations, you have access to the attributes. However, in 9.2, there are a whole new set of facilities for database replication. And what we would suggest as a workflow in that situation, where you have a master database that you want some people not to be able to edit, but they do want to use representations, is that you use the replication facilities to clone a subset of the data into a database that they do have access to. Similarly, to stress about the license levels, you do need an Arc editor or above in order to do overrides. You cannot create and edit representations with just an Arc view license. The Arc editor level is the license level which is targeted at cartographic production, at building and maintaining cartographic databases, and that's the minimum license level needed for doing that. In fact, some of the facilities that Peter was showing, the automation facilities, because those make use of the geoprocessing tools, those require an ArcInfo level license on the system to do that sort of automation. But very often you only need one of those licenses on a whole system. Let's take a few of the other sort of simpler questions when I can find them again. Question saying, when you edit the vertices, where does it save the changes? And by default, and in the usual case, it goes into this override field. Remember that when you created the representation, it added 2 columns, and the second one of those was an override, a blob field, which started empty. It remains empty for most features, but for those few features, ones around the edge of the map or things where you want to change things away from their true geographic position, then all those changes go into that blob field, regardless of whether they're changes to position, changes to color, changes to thickness, etc. Is there going to be a tutorial available for representations? Yes, there is. It's there. It ships with 9.2, which then raises the question asked, when does 9.2 ship? I can't answer that directly as to when you'll get it, because it depends where in the world you are, etc. But I can say that 9.2 desktop has frozen from development. It's gone into the manufacturing and quality and shipping process. So we would expect it to be shipping to some people at least later this year, but don't quote me on that. So, question, could representations be used to graphically display where pipes cross over each other without connecting? And there's another question similarly about roads, bridges. And yes, in those automation tools, there are several tools which produce representations that are dependent on more than one feature. At draw time, the geometric effects are a single feature at a time. But there are some forms of cartography, such as bridges and embankments, which are really presentations of multiple features. So we provide in the cartography toolbox a set of tools for creating overpasses, creating underpasses, etc., that can greatly simplify and automate the task of doing these sorts of presentations. Somebody was saying, can I keep my information in a separate table and use relates or joins for it? The answer there is no. For performance reasons, those 2 columns have to be firmly attached to the master feature class. Okay, I think we're out of time in terms of questions here. I'll pass back to Peter to terminate. Thank you.
Thank you, Paul. And again, thank you for your questions. Brief review. It's time for you to evaluate your current symbology. What cartographic representations will allow you to do is fill in the gaps and store what may currently be too complex for ArcGIS. In addition, using some of the geoprocessing tools, you should reevaluate your current cartographic workflow. Where are you spending your time now, and what can you automate or streamline? So that's the basic 2 messages that you can take away today to start preparing your data and your map production workflows to take advantage of the 9.2 tools when they ship. So we're pretty much out of time. Before we go, I'd like to leave this page up for a few moments with my closing comments to point you to a couple more resources. Again, point out the ArcGIS 9.2 desktop help system is currently available both from that link, but you could also go to our support site at support.esri.com, and there's a link right there on the front page that you can use to access that desktop help and read up on what we're looking at here. Some additional literature and online resources as well. But moving back to the live training seminar, we would like you to help us improve them. Please take a moment to complete our survey. Click the Give Us Feedback link on this page, and take a couple of moments to give us your feedback. And we hope you have enjoyed today's seminar, and on behalf of ESRI, I'd like to thank you all for attending.